Assalamualaikum warahmatullahi taala wabarakatuh. Bismillahirrahmanirrahim. So we continue our class today. Today we need to understand the ratio. So the ratio gamma between the CPM over the CVM. So today just to understand the ratio between the CPM over the CVM. So and then of course we refer as the ideal gas. Then PV is equal and RT is the ideal gas equation. Okay, so we continue. Okay, so 1 mole N is equal to 1. N is symbol of mole. 1 mole of the ideal gas with the F degrees. So degree of freedom. F degrees of freedom at temperature T. So the unit is a Kelvin. So has internal energy. So have the internal energy U. The unit is a joule. As we refer to this equation, internal energy is equal N number of mole F over 2 RT. F is the degree of freedom, R is the gas constant, and T is the temperature in Kelvin. Okay, so then because we take N is equal to 1, so we can get this equation. The internal energy is equal to F over 2 RT, where in this case we take N is equal to 1. Then we continue, so we derive both sides of this equation. Delta U is equal F over 2 R delta T. Then we can write as a delta U over delta T is equal to the F over 2 R. So we can get this equation. Okay. So we continue. So ideal gas at a constant volume. So ideal gas at a constant volume, delta Q is equal to delta U plus W. This equation is the equation of the first law of thermodynamics. So delta Q is equal to the delta U plus the W. Okay, so because this one is the ideal gas at constant volume, that means the work is equal to the P pressure delta V. Because the volume is constant, so delta V is equal to 0. Therefore, the W is equal to 0. So this W is equal to 0. Then we can write the first law of thermodynamics as a delta Q is equal to delta U. Okay, so delta Q, because we refer at the constant volume, so we can write as a NCVM delta T. So the delta Q is equal to the NCVM delta T equals to the delta U. Okay. And then because we refer the number of mole as 1, so from this equation, we can write as a delta U over the delta T is equal to the CVM. So rearrange this equation, then we can get this equation. Delta U over delta T is equal CVM. Then we continue. So CVM is equal to delta U over delta T. Then we knew that delta U is over delta T is equal to the FR over 2. So this is from this equation from here. So this is referred to here. Then we replace delta U over delta 2 as the FR over 2. Then we can get this equation. So molar heat capacity at a constant volume equal to the F over 2 R. So this one is the first equation related to the CVM. Okay, so hope we understand how to get this equation. Okay, so we continue. So from Cpm minus Cvm is equal to R. Okay, so this the student need to refer to the notes. Okay, so please refer to the notes. Okay, Cpm minus Cvm equals to the R. And then we can write as a Cpm equals to the R plus the Cvm. And then R plus, we replace the Cvm with this F2 over R. Therefore, you can get the equation Cpm as a F bracket F plus 2 over 2 close bracket R. Then we can get this equation related to the Cpm, molar heat capacity at constant pressure, as a F over 2, F plus 2 over 2 times R. So this one is the equation for the molar heat capacity at constant pressure. This one is a molar heat capacity at constant volume. So we have this equation number 1, then also the equation number 2. Okay, so we continue. Okay, so we continue. So we continue, therefore, so we find the ratio. So we find the ratio here, Cpm over the Cvm. So we replace the Cpm as a F over 2, F plus 2 over 2 R. And then for the Cvm as a F over 2 R. Then we rearrange this equation. And then at last, we have this equation. So the ratio Cpm over Cpm, Cpm over the Cvm or the gamma as a F plus 2 over F. So F is a degree of freedom. Okay, and then we know this equation. Okay, so and then we apply to the monatomic gas, single atom gas, diatomic gas, 2 atomic. So we have 2 atoms of gas, and then here is a polyatomic gas, more than 2. Okay, so F is equals to 3 degree of freedom for the monatomic gas. So please refer to the last note, the note before this. So F is 3, and then we apply to this equation, and then we have the ratio gamma is equal to the 1.67. Okay, and then we go for the diatomic gas. Then the degree of freedom for the diatomic gas is F is equals to 5. Then we apply to this equation, and then we get the ratio gamma is equal to 1.4 for the atomic gas, diatomic gas. And we refer to the polyatomic gas, degree of freedom is F equal to 6. And then we apply to this equation, and then at the last we can get the ratio of the gamma is equal to 1.33. So this one for the polyatomic gas. Okay, so that means the ratio of the gamma we can use to know either the gas is a monatomic gas, diatomic gas, or the polyatomic gas by we know the ratio of the CPM over the CVM. So for example, in the calculation, we get the ratio of the gamma is 1.4. That means the gas actually is your diatomic gas. If we get the ratio of the gamma is 1.33, that means the gas is a polyatomic gas. So that is a thank you.